What if I told you that the edge of the universe isn't just far away, it's impossible? Not impossible to reach, but impossible to exist. Right now, as you watch this video, you're standing at the center of something that has an edge you can see, but that edge isn't the same for anyone else. In fact, every person who has ever lived stood at the exact center of their own universe, with their own unique edge. And here's what will absolutely destroy your understanding of reality. That edge is racing away from you faster than light itself, carrying with it entire galaxies that will eventually become so distant that future civilizations will never even know they existed. The universe's edge isn't a wall, it isn't a boundary, it isn't even a place. It's something so much stranger that when you truly understand it, you'll realize you've been asking the wrong questions your entire life. The edge of the universe is a time machine, a horizon of impossibility, and a mirror reflecting the very moment of creation itself. And by the end of this deep dive, you're going to understand why the universe's edge might actually prove that we live in something far more bizarre than we ever imagined. Before we journey to the literal edge of everything, hit that like button, because this video took months of research to put together, and subscribe so you don't miss the mind-bending content we release every week. Also, drop a comment right now telling me what country you're watching from and what time it is where you are. I'm genuinely curious to see how far across the globe this video reaches, and I read every single comment. Now, let's begin at the beginning, because that's where the edge actually lives. When you look up at the night sky, you're not just looking out into space, you're looking backward in time. This isn't poetic language, it's literal physics. Light takes time to travel, which means when you see a star that's 100 light years away, you're seeing it as it was 100 years ago. That star might not even exist anymore. It could have exploded into a supernova decades ago, but the light from that explosion hasn't reached us yet. So when we see that star twinkling peacefully in the night sky, we're essentially watching a ghost, a phantom echo of something that might already be dead. Now, here's where things get interesting. If light takes time to travel, and the universe has only existed for a finite amount of time, that means there's a maximum distance from which light has had time to reach us. That distance defines something called our cosmic horizon, and that, in the most practical sense, is the edge of our observable universe. But here's the thing that most people don't realize. That edge isn't the edge of the universe itself. It's just the edge of what we can see. Think of it like standing in the middle of an enormous foggy field at dawn. You can see maybe 100 meters in every direction before the fog becomes too thick. That visible circle around you, that's your horizon. But the field doesn't end at your horizon. The field continues beyond it. You just can't see it. Now imagine that fog is constantly clearing, but the field is also expanding. Every moment you can see a little bit farther, but there's always more field appearing beyond what you can see. That's essentially what's happening with our universe. The observable universe, the part we can see, has a radius of about 46 billion light years. Now, wait a second. You might be thinking, if the universe is only about 13.8 billion years old, how can we see things that are 46 billion light years away? Shouldn't light have only had time to travel 13.8 billion light years? This seems like it violates the laws of physics, and this apparent paradox is actually our first clue that the edge of the universe is far stranger than a simple boundary. The answer lies in cosmic expansion. While light has been traveling toward us for 13.8 billion years, the space between us and the source of that light has been expanding the entire time. So an object that emitted light 13.8 billion years ago, when the light started its journey, wasn't 46 billion light years away from us. It was much closer. But during the billions of years it took that light to reach us, the space between us and that object was stretching, carrying that object farther and farther away. By the time the light reaches us, the object that emitted it is now 46 billion light years away, even though the light itself only traveled through time for 13.8 billion years. This is a critical concept to understand. Space itself is expanding. Galaxies aren't just moving through space away from each other, like shrapnel from an explosion. The space between galaxies is literally growing, like dots drawn on the surface of a balloon that's being inflated. As the balloon expands, the dots get farther apart, not because they're moving across the surface of the balloon, but because more balloon surface is appearing between them. This was one of the most revolutionary discoveries in the history of science, and it was made by a man named Edwin Hubble in 1929. Hubble was observing distant galaxies and noticed something peculiar. The light from these galaxies was shifted toward the red end of the spectrum, a phenomenon called redshift. This happens because of the Doppler effect, the same effect that makes an ambulance siren sound higher pitched as it approaches you and lower pitched as it moves away. When light from a galaxy is redshifted, it means that galaxy is moving away from us. But Hubble noticed something even more remarkable. The farther away a galaxy was, the faster it appeared to be moving away from us. This relationship, now called Hubble's law, revealed that the universe itself is expanding uniformly in all directions. Every galaxy is moving away from every other galaxy, not because they're traveling through space, but because space itself is growing. Now, here's what will blow your mind. If the universe is expanding uniformly in all directions, that means no matter where you are in the universe, you'll observe the exact same thing. Every observer on every planet in every galaxy sees themselves at the center of the expansion. There is no privileged location, no cosmic center. The universe has no center, or more accurately, every point is the center from its own perspective. This brings us to a profound realization about the edge of the universe. When we talk about the edge of the observable universe, we're talking about our cosmic horizon, the maximum distance from which light has had time to reach us since the Big Bang. But someone in a galaxy at the edge of our observable universe would have their own cosmic horizon, extending 46 billion light years in all directions from their location. Some of the galaxies they can see would be beyond our cosmic horizon, forever invisible to us. So the universe doesn't have one edge. It has infinite edges, one for every observer. Your cosmic horizon is different from mine, which is different from an alien's on a planet orbiting a star in the Andromeda galaxy. We each stand at the center of our own observable universe, surrounded by our own personal cosmic horizon. The edge of the universe is not a place, it's a perspective. But here's where things get truly mind-bending. Because space is expanding, and because that expansion is accelerating, there are galaxies at the edge of our observable universe that are moving away from us faster than the speed of light. Now, you are probably taught that nothing can move faster than light, and that's true. Nothing can move through space faster than light. But space itself has no such speed limit. Space can expand at any rate, carrying galaxies along with it, and those galaxies can recede from us faster than light without violating Einstein's special relativity. This creates something called the cosmic event horizon, and it's distinct from the cosmic particle horizon we've been discussing. The particle horizon is the edge of the observable universe, the maximum distance from which light has had time to reach us. The event horizon is the edge beyond which events happening right now will never be observable to us in the future, no matter how long we wait. Because space is expanding faster than light between us and those distant regions, light leaving those regions now will never catch up to us. It will be carried away by the expansion of space, forever retreating, never closing the distance. Think about that for a moment. There are things happening right now, in this very second, at the cosmic event horizon that we will never see. Not because we don't have powerful enough telescopes, but because the light from those events will never reach us. It's cosmologically impossible. Those events are beyond the edge of what can ever influence us, or what we can ever observe. In a very real sense, those events are outside our universe. And here's the truly disturbing part. As space continues to expand, and that expansion continues to accelerate, the cosmic event horizon is actually getting closer to us. Galaxies that are currently observable to us are crossing that event horizon, disappearing from our observable universe forever. Right now, as you watch this video, there are galaxies whose light is reaching us for the last time. In a few million years, those galaxies will have receded so far that their light will be permanently redshifted beyond our ability to detect. They will fade from view, not because they've gone dark, but because the space between us and them has grown so vast that light cannot bridge the gap. In the far future, trillions of years from now, if intelligent civilizations arise and look out at the cosmos, they will see a much emptier universe than we do. Most galaxies will have disappeared beyond their cosmic event horizon. They will see only their local group of gravitationally bound galaxies, a small island of matter in an ocean of expanding darkness. And with no distant galaxies to observe, no cosmic microwave background radiation redshifted beyond detection, those future civilizations will have no evidence that the Big Bang ever occurred. They will be unable to discover the true history and nature of their universe because the expansion of space will have erased the evidence. This raises a chilling question. What evidence of the universe's true nature has already disappeared beyond our cosmic event horizon? What could we have learned about the cosmos if we had existed billions of years earlier, when more of the universe was observable? Are there fundamental truths about reality that are now forever beyond our ability to discover, because the parts of the universe that contained that evidence have receded beyond our reach? We're only 20 minutes in, and we've already discovered that the edge of the universe isn't a place. It's a perspective that differs for every observer. We've learned that space itself is expanding, carrying galaxies away from us faster than light, and creating a cosmic event horizon beyond which events can never affect us. But we haven't even scratched the surface of how strange this edge really is. Because when we look at the edge of the observable universe, we're not looking at a distant place, we're looking at a distant time. And that time is the moment of the universe's birth. Now, before we go deeper into the cosmic horizon and what it reveals about the beginning of everything, let me ask you this. Has your mind been blown yet? Because we're just getting started. If you're enjoying this journey to the edge of reality, make sure that like button is glowing blue. And if you haven't subscribed yet, do it now, because this channel is all about exploring the most mind-bending mysteries of our universe. Okay, let's keep going. When you look out into space, you're looking back in time. We established that. The light from the sun takes 8 minutes to reach Earth. So when you see the sun, you're seeing it as it was 8 minutes ago. The light from the nearest star, Proxima Centauri, takes about 4 years to reach us. The light from the Andromeda Galaxy takes 2.5 million years. The farther out we look, the farther back in time we see. So what happens when we look as far out as possible, all the way to the edge of the observable universe? We see the universe as it was 13.8 billion years ago, shortly after the Big Bang. The most distant light we can observe comes from an era when the universe was only 380,000 years old. This ancient light is called the cosmic microwave background radiation, or CMB, and it's essentially a baby picture of the universe, a snapshot of what the cosmos looked like in its infancy. The cosmic microwave background was discovered accidentally in 1964 by two scientists named Arno Penzias and Robert Wilson. They were testing a sensitive radio antenna at Bell Labs in New Jersey and kept detecting an annoying background noise that they couldn't eliminate. No matter where they pointed their antenna, no matter what time of day or what season, the noise was always there, a faint, persistent hiss coming from all directions equally. At first, they thought it might be interference from New York City, or maybe pigeons nesting in their antenna. They even cleaned out the pigeon droppings, but the signal persisted. Eventually, they realized they had discovered something extraordinary. That persistent noise wasn't interference or malfunction. It was the echo of the Big Bang itself, the afterglow of creation, stretched and cooled by 13.8 billion years of cosmic expansion. The cosmic microwave background is a wall of light that surrounds us in all directions, marking the edge of the observable universe in time. Before this moment, 380,000 years after the Big Bang, the universe was opaque. It was so hot and dense that light couldn't travel freely. Photons would be emitted and immediately absorbed by free electrons, over and over, trapped in an endless cycle. The universe was like a thick fog, completely opaque to light. But as the universe expanded and cooled, something remarkable happened. The temperature dropped enough that electrons and protons could combine to form neutral hydrogen atoms, a moment called recombination. Once electrons were bound up in atoms, they could no longer scatter photons, and light was suddenly free to travel unimpeded through space. The fog cleared. The universe became transparent, and the light that was released at that moment has been traveling through space ever since, stretched by cosmic expansion from visible light into microwaves. This is the cosmic microwave background, and it represents an absolute limit to how far back in time we can see using light. We cannot observe anything older than the CMB, because before that moment, the universe was opaque. It's like trying to see through a frosted glass window. You can see the glass itself, but you cannot see what's behind it. The cosmic microwave background is our frosted glass window, and behind it lies the first 380,000 years of the universe's history, forever hidden from direct observation. But here's what's truly profound. When we observe the cosmic microwave background, we're not looking at a specific place in the universe. We're looking at a specific moment in time that's happening all around us. Imagine you're standing in the middle of a giant expanding sphere. The surface of that sphere represents the moment in the universe's history when the CMB was emitted. As the universe expands, that sphere grows larger, and we see different parts of it over time. But no matter how long we wait, we're always seeing the same moment in cosmic history, just from different spatial locations. The edge of the observable universe isn't a boundary in space. It's a boundary in time. It's the earliest moment we can observe, and it surrounds us in all directions like a vast cosmic bubble. We are trapped inside this bubble of observability, unable to see beyond it, not because of technological limitations, but because of fundamental constraints imposed by the speed of light and the age of the universe. Now, let's think about what the cosmic microwave background reveals about the early universe. Scientists have measured the CMB with extraordinary precision, most notably with the Planck satellite, which mapped the temperature variations across the entire sky with incredible detail. And what those measurements reveal is shocking. The cosmic microwave background is almost perfectly uniform. In every direction we look, the temperature is almost exactly the same, varying by only about 1 part in 100,000. This presents a massive problem called the horizon problem. The cosmic microwave background comes from regions of space that are now 92 billion light-years apart, on opposite sides of the observable universe. But in the early universe, when the CMB was emitted, those regions were so far apart that light couldn't have traveled between them. They had never been in causal contact. They had never communicated or exchanged information or energy. So how could they have the same temperature? If you put 2 cups of water in separate rooms and never allow them to exchange heat, you wouldn't expect them to end up at the exact same temperature. But that's essentially what we observe with the CMB. Regions that could never have communicated or exchanged heat are nevertheless at the same temperature to extraordinary precision. This shouldn't be possible. The solution to this problem is one of the most mind-blowing ideas in all of cosmology. It's called cosmic inflation, and it was proposed by physicist Alan Guth in 1980. Inflation theory suggests that in the first fraction of a second after the Big Bang, specifically between about 10 to the minus 36 seconds and 10 to the minus 32 seconds. The universe underwent a period of exponential expansion, growing by a factor of at least 10 to the 26 in an incomprehensibly brief instant. During inflation, a tiny patch of space, smaller than a subatomic particle, expanded to become larger than the observable universe. All the regions we now see in the cosmic microwave background, regions that appear impossibly far apart, were once crammed together in that tiny patch before inflation. They were in thermal contact, they reached the same temperature, and then inflation blasted them apart faster than light, separating them to opposite sides of the cosmos. Inflation solves the horizon problem, but it creates an even stranger picture of the universe. If inflation happened, then the observable universe, everything we can see out to the cosmic horizon, is just a tiny, tiny fraction of the whole universe. The universe beyond our cosmic horizon is vastly larger, perhaps infinitely larger than what we can observe. We are like bacteria living on a single grain of sand on an endless beach, convinced that our grain of sand is all that exists because we cannot see beyond it. But here's where inflation leads to truly disturbing conclusions. During inflation, quantum fluctuations in the inflating field were stretched to cosmic scales. These tiny quantum jitters became the seeds of all structure in the universe, the slight density variations that eventually collapsed to form galaxies, stars, and planets. The pattern of these fluctuations is imprinted on the cosmic microwave background as those tiny temperature variations that Planck measured. Now, quantum mechanics is inherently probabilistic. Quantum fluctuations are random. But because we can observe the pattern of fluctuations in the CMB, we can see which random configuration actually occurred in our observable universe. However, in regions beyond our cosmic horizon, in parts of the universe too far away for us ever to see, inflation would have produced different random configurations. This means the laws of physics, the fundamental constants of nature, the arrangement of matter and energy, everything that makes our universe the way it is, might be different in those distant regions. Beyond our cosmic horizon might lie domains of reality where the electromagnetic force is stronger, where stars form differently, where life as we know it is impossible. Or there might be regions where the constants are just slightly different, producing a universe eerily similar to ours, but with subtle variations. And if the universe beyond our horizon is infinite, as many inflation models suggest, then every possible configuration of matter and energy, every possible variation of physical laws within the range allowed by the underlying theory must occur somewhere, including configurations identical to our observable universe, including configurations identical to our solar system, our planet, our lives, but with small differences. There could be infinite copies of you out there beyond the cosmic horizon, living lives almost identical to yours, but making different choices at key moments. This is not science fiction. This is a serious implication of our best theories about cosmic inflation and the nature of the universe beyond the edge of observability. The edge of our universe might not just separate us from more space. It might separate us from other domains of reality with different physical laws, different histories, different versions of ourselves. Let me pause here and ask you to consider what this means. Everything you can see, everything humanity has ever observed, every star and galaxy in cosmic structure, all of it exists within a bubble of observability bounded by our cosmic horizon. And that bubble is a minuscule fraction of what might exist beyond. The edge of your universe is not a wall, it's a veil, separating you from a cosmos far vaster and stranger than anything you can observe. Do you feel small yet? You should. But stick with me, because it gets even stranger. We're about 50 minutes in, so if you're still here, you're clearly someone who loves deep intellectual exploration. Give yourself a pat on the back, and give this video a like if you haven't already. We're going to keep building on these concepts, and the payoff is going to be enormous. So we've established that the edge of the observable universe is a horizon in both space and time, showing us the universe as it was 13.8 billion years ago. We've learned about cosmic inflation and how it implies the existence of a vast, possibly infinite universe beyond what we can observe, potentially containing regions with different physical laws and infinite copies of ourselves. But there's an even stranger aspect to the universe's edge that we need to explore. What is the edge actually expanding into? When most people hear that the universe is expanding, they imagine the universe as a giant sphere growing larger, like a balloon inflating. And they naturally ask, what is outside the sphere? What is the universe expanding into? The answer is deeply counterintuitive. The universe isn't expanding into anything. There is no outside. Space itself is all there is. This is incredibly difficult to wrap your mind around, because every expansion you've ever witnessed in your everyday life involves something expanding into a pre-existing space. A balloon expands into the room. A city expands into the surrounding countryside. But the universe doesn't work that way. The universe is space itself, and when the universe expands, more space comes into existence. There's no container, no surrounding void, no outside. Think of it this way. Imagine you're a two-dimensional creature living on the surface of a balloon. Your entire universe is the balloon's surface. Now imagine the balloon is being inflated. From your perspective as a two-dimensional creature, your universe is expanding. The distance between any 2 points on the surface is increasing. But the balloon isn't expanding into anything from your perspective, because you cannot perceive the third dimension. There is no outside from within your two-dimensional reality. The balloon's surface is all that exists. Now, apply that same logic to our three-dimensional universe. We are like those two-dimensional creatures, but we live in 3 dimensions of space. When our universe expands, the space we inhabit is growing, but it's not expanding into a higher dimensional space that we can perceive or access. From within the universe, there is no outside. Space is all there is. But this raises a profound question. If the universe isn't expanding into anything, what exactly is expanding? The answer is that the metric of space itself is changing. The metric is essentially a mathematical description of the distances between points. When space expands, the distances between points increase, not because the points are moving through space, but because the metric itself is changing. More space is coming into existence between those points. This is described by Einstein's general theory of relativity, published in 1915. General relativity revolutionized our understanding of space, time, and gravity. Instead of treating space and time as fixed, unchanging backdrops against which events occur, general relativity revealed that space and time are dynamic, flexible entities that can bend, warp, and stretch in response to matter and energy. In general relativity, gravity isn't a force in the traditional sense. Instead, mass and energy curve spacetime, and objects move along the curves. Imagine placing a bowling ball on a stretched rubber sheet. The ball creates a depression in the sheet, and if you roll a marble near the bowling ball, the marble will curve toward it, following the depression. That's essentially how gravity works in general relativity. Massive objects curve spacetime, and other objects move along those curves. The expansion of the universe is also described by general relativity. In fact, Einstein's equations predicted that the universe should be either expanding or contracting. It cannot be static. When Einstein first made this discovery, he was disturbed by it because he, like everyone else at the time, believed the universe was eternal and unchanging. So Einstein added a term to his equations called the cosmological constant, a kind of anti-gravity that could hold the universe static against the pull of gravity. But after Hubble's discovery in 1929 that the universe is expanding, Einstein reportedly called the cosmological constant his biggest blunder. He had been on the verge of predicting the expansion of the universe from pure theory, But he had let his preconceptions blind him to what his equations were telling him. It's a powerful reminder that even the greatest minds can be led astray by assumptions about how the universe should be. Ironically, the cosmological constant has made a comeback. In 1998, two teams of scientists led by Saul Perlmutter, Brian Schmidt, and Adam Rees were studying distant supernova to measure the rate of cosmic expansion. They expected to find that the expansion was slowing down due to the gravitational pull of all the matter in the universe. Instead, they discovered that the expansion is accelerating. Galaxies are moving apart faster and faster over time. This was one of the most shocking discoveries in the history of astronomy, and it earned those scientists the Nobel Prize in Physics in 2011. The acceleration of cosmic expansion implies the existence of a mysterious form of energy permeating all of space, pushing everything apart. This energy is called dark energy, and it makes up about 68% of the total energy content of the universe. We don't know what dark energy is, but its effects are unmistakable, and it's the reason the cosmic event horizon exists. Because dark energy is causing the universe's expansion to accelerate, distant galaxies are receding from us ever faster. Eventually, they'll be receding so fast that light from them can never reach us, creating that cosmic event horizon we discussed earlier. Dark energy is literally tearing the universe apart, pushing the edge of observability closer and closer, isolating us more and more from the rest of the cosmos. Now, here's a disturbing thought experiment. If dark energy continues to accelerate the universe's expansion forever, what happens in the far future? Eventually, the universe will enter a phase called the Big Rip. The expansion will become so rapid that even gravitationally bound structures like galaxies, solar systems, planets, and eventually atoms themselves will be torn apart. Space will be expanding so fast that even the forces holding matter together won't be strong enough to resist. In the final moments before the Big Rip, atoms will be stretched and torn apart. Electrons will be ripped from their nuclei. Nuclei will be shredded into individual protons and neutrons. And finally, even protons and neutrons will be disintegrated into quarks and gluons. The universe will end not with a whimper or a bang, but with a rip, a catastrophic tearing of the fabric of reality itself. Now, the Big Rip is just one possible fate for the universe, and it depends on the properties of dark energy, which we don't fully understand. But it's a legitimate possibility based on current observations, and it illustrates just how violent and strange the universe's expansion can become. The edge of the universe isn't just moving away from us. It might eventually tear everything apart, including the atoms in your body, in some distant future. But let's return to the present and consider another strange implication of the universe's edge. We've talked about the observable universe, the region within our cosmic horizon from which light has had time to reach us. But what about the universe beyond that horizon? Does it even exist if we can never observe it? This is not just a philosophical question. It gets at the heart of what we mean by existence. In science, we generally accept that something exists if it has observable effects, if it can interact with us or influence us in some measurable way. But regions beyond the cosmic event horizon can never influence us, can never send us information, can never interact with us in any way. From an operational standpoint, they might as well not exist. They are causally disconnected from us, forever beyond the reach of observation or influence. Yet our best theories tell us those regions do exist, that they're physically real, governed by the same laws of physics, filled with galaxies and stars, and perhaps life. The edge of the observable universe isn't the edge of reality itself. It's just the edge of what's accessible to us. There's a whole universe out there beyond the horizon, existing independently of our ability to see it. This creates a strange tension. On one hand, we have strong theoretical reasons to believe in the reality of the universe beyond our horizon. On the other hand, that reality is forever inaccessible, unverifiable, beyond the reach of empirical science. We're forced to rely on theory alone, extending our models beyond the domain where they can be tested. Some physicists are comfortable with this. They argue that our theories of cosmology and inflation are so well tested within the observable universe that we should trust their predictions beyond the horizon. Other physicists are more skeptical, arguing that we shouldn't believe in things we can never verify, that science should restrict itself to the observable. This debate touches on deep questions about the nature of scientific knowledge and the limits of empiricism. Can we ever truly know what lies beyond the edge of observation? Or are we forever confined to speculation, building models that might describe reality beyond the horizon, but can never be confirmed? And here's an even stranger thought. If the universe beyond our horizon is real, but forever unobservable, then in what sense does it exist for us? Does existence require observability, or is existence independent of observation? These are questions that blur the line between physics and philosophy, between science and metaphysics. Some interpretations of quantum mechanics suggest that observation plays a fundamental role in determining what's real. In the Copenhagen interpretation, for example, quantum systems exist in a superposition of all possible states until they're observed, at which point they collapse into a single definite state. If you take this interpretation seriously and apply it to cosmology, you might argue that regions of the universe beyond our horizon exist in a kind of quantum superposition, neither real nor unreal, until they become observable. This is highly speculative, and most physicists don't take this view, but it illustrates how questions about the edge of the universe lead us into deep conceptual territory. The universe's edge isn't just a physical boundary. It's a boundary of knowledge, of causality, of existence itself. We're now about 75 minutes in, and we've journeyed from the practical limitations of observability to the philosophical implications of a universe that extends beyond what we can ever see. We've grappled with questions about existence, observation, and the limits of scientific knowledge. But now I want to bring this back to you personally, because the universe's edge isn't just an abstract concept. It has profound implications for how you understand your place in reality. Before we get there, let me remind you one more time to like this video and subscribe to the channel. We're creating some of the most in-depth, mind-expanding content on YouTube, and your support makes it possible. Also, I'm still curious about where you're watching from and what time it is. Drop that in the comments if you haven't already. So let's talk about what the universe's edge means for you personally. You are at this very moment standing at the exact center of the observable universe. This isn't because you're special or privileged. It's because the observable universe is defined by what can be observed from your location. Your cosmic horizon extends equally in all directions from where you are, making you the center of your own observable cosmos. Every person who has ever lived occupied the same position. They too stood at the center of the observable universe, surrounded by their own cosmic horizon. And every person who will ever live will occupy the same position. The universe has no objective center. Every observer is equally central from their own perspective. This is both humbling and empowering. It's humbling because it reveals that there's nothing objectively special about your location. The universe doesn't revolve around you. You're not at the center of anything absolute. But it's empowering because it means you are the center of your own observable reality. Your perspective is unique. No one else sees exactly the same cosmic horizon you do. Now, let's think about what you're actually seeing when you look out at the universe. Remember, looking out in space is looking back in time. When you look at the night sky, you're seeing a timeline of cosmic history, with nearby objects appearing as they were recently, and distant objects appearing as they were long ago. The edge of your observable universe, the cosmic microwave background, shows you the universe as it was 13.8 billion years ago. But here's something most people never consider. You are made of atoms that were forged in the cores of stars that died billions of years ago. The carbon in your cells, the oxygen you breathe, the calcium in your bones, all of it was created by nuclear fusion in the hearts of massive stars that exploded as supernova, scattering their enriched material into space. That material eventually coalesced into new generations of stars and planets, including the Sun and Earth, and eventually into you. In a very real sense, you are stardust. You are the universe observing itself. The atoms in your brain, the neurons firing as you process these words, are ancient cosmic matter that has become conscious and is now contemplating its own origins and the edge of the observable cosmos. You are not separate from the universe. You are a part of it, a temporary configuration of cosmic matter that has organized itself into something capable of understanding. This perspective can be both awe-inspiring and existentially challenging. On one hand, it connects you to the cosmos in a profound way. You are not an outsider looking at the universe from a distance. You are the universe experiencing itself from the inside. On the other hand, it can make you feel insignificant. If you're just a temporary arrangement of atoms in a vast, expanding cosmos, what meaning does your life have? But here's a perspective that might change how you think about this. Yes, the universe is vast beyond comprehension. Yes, you are tiny compared to the cosmic scale, but you are also incredibly complex. The number of neurons in your brain exceeds the number of stars in the Milky Way galaxy. The complexity of your consciousness, your ability to think, feel, love, create, understand, is arguably more remarkable than the size of the universe. And here's something even more profound. You are capable of understanding the universe's edge. Your brain, a collection of atoms formed in stellar furnaces billions of years ago, has organized itself into patterns capable of comprehending cosmic horizons, general relativity, quantum mechanics, and the fundamental nature of reality. That's extraordinary. In the entire observable universe, as far as we know, only on this one planet, in the brains of one species, has matter organized itself to this level of complexity and understanding. You might be small, but you're not insignificant. You're one of the ways the universe has become conscious of itself, one of the rare places where cosmic matter has achieved the ability to contemplate the cosmos. The edge of the universe exists for you because you exist to observe it. Without conscious observers, cosmic horizons would be physically real, but experientially meaningless. Now, let's consider how the universe's edge shapes your existence in practical ways. Because of the finite speed of light and the age of the universe, you are causally isolated from most of the cosmos. The vast majority of what exists is beyond your cosmic horizon, forever incapable of affecting you. You are, in essence, living in a cosmic island, isolated by the limits of light speed and cosmic expansion. But that isolation also creates possibility. The future is not determined by distant cosmic events, because those events can never reach you. Your choices, your actions, your life unfolds within your cosmic island, shaped by local circumstances and quantum probabilities, not by some predetermined cosmic plan. The edge of the universe guarantees you a degree of freedom, a space where your decisions matter and shape your local reality. At the same time, the universe's edge is a reminder of limits. There are things you will never know, places you will never see, questions you can never answer, because the evidence lies beyond the cosmic horizon. Humans have always pushed against limits, explored frontiers, sought to expand the boundaries of knowledge. But the cosmic horizon represents an absolute limit, a boundary that cannot be crossed, no matter how advanced our technology becomes. How do you respond to that? Some people find it frustrating, a fundamental constraint on human curiosity and ambition. Others find it liberating, a reminder that not everything needs to be known or conquered, that there's a kind of beauty in mystery. The universe's edge teaches us humility, the acceptance that some things will always lie beyond our reach, and that's okay. But here's where things get really interesting. The edge of your observable universe is not static. it's changing. Every second, light from more distant regions reaches Earth for the first time, expanding the radius of our observable universe. We are constantly seeing farther into space and deeper into time. The cosmic horizon is gradually revealing more of the universe's history to us. However, because of the acceleration of cosmic expansion driven by dark energy, the cosmic event horizon is actually moving closer. While we can see farther back in time as the universe ages, the regions of space that can ever influence us in the future are shrinking. It's a strange paradox. Our view into the past is expanding while our connection to the cosmic present is contracting. This means humanity exists in a special time in cosmic history. We live in an era when the evidence of the Big Bang, the cosmic microwave background, and the large-scale structure of the universe are all observable. In the far future, as we discussed earlier, civilizations will see a much emptier universe. They'll be denied the evidence we have access to. We are living in what might be called the golden age of cosmological discovery, a brief window in the trillion-year history of the universe, when intelligent observers can piece together the cosmos's true nature. This should make you appreciate the present moment. You live at a time when humans have developed the technology and theoretical framework to understand the universe's edge, its expansion, its origin. A few hundred years ago, this would have been impossible. A few trillion years from now, it might be impossible again. You exist in a narrow slice of cosmic history when the universe is revealing its secrets. And you're not just passively receiving this information. You're participating in the greatest intellectual endeavor in human history, the quest to understand the cosmos. By watching this video, by engaging with these ideas, you're part of that endeavor. You're carrying forward the torch of curiosity that has driven human beings to map the stars, calculate the orbits of planets, split the atom, and peer back to the edge of time itself. Now, let's talk about something that might completely change your relationship with the universe's edge. We've been discussing the observable universe as if it's a fixed, objective thing. But remember, every observer has their own unique cosmic horizon. Your observable universe is centered on you and extends 46 billion light years in all directions. But someone on a planet in a galaxy 10 billion light years away has their own observable universe centered on them. Some of the galaxies in their observable universe are not in yours. They can see things you cannot, and you can see things they cannot. Your observable universes overlap, but they're not identical. Now extend this idea. Every conscious being in the cosmos has their own unique observable universe. There are potentially trillions upon trillions of different cosmic horizons, one for each observer. This means the concept of the edge of the universe is deeply subjective. It's not that there's one objective edge and everyone sees it differently. It's that the edge itself is observer-dependent. The universe doesn't have a single edge. It has as many edges as there are observers, each one equally valid from its own reference frame. This has profound implications. It means that objective reality, the totality of what exists, is larger than any single perspective can encompass. No one observer, no matter how advanced, can ever see the whole picture. The complete universe, if such a concept even makes sense, is only accessible by combining infinite perspectives, each offering a unique window into a different region of spacetime. You are one of those windows. Your life, your consciousness, your perspective is a unique vantage point on reality that has never existed before and will never exist again. When you die, your particular cosmic horizon, your unique observable universe, vanishes with you. No one else will ever see exactly what you see or experience exactly what you experience. This makes your perspective precious. You're not just a passive observer of a pre-existing reality. You're actively participating in creating the structure of observable reality through your presence. Without you, your particular cosmic horizon wouldn't exist. The universe would be missing one of its windows onto itself. Let me share something that might blow your mind even further. Some interpretations of quantum mechanics, particularly the many worlds interpretation proposed by Hugh Everett in 1957, suggest that every quantum measurement causes the universe to split into multiple branches, with each possible outcome occurring in a different branch. If this is true, then not only does every observer have their own cosmic horizon, but every observer exists in multiple branches of reality, each with their own slightly different version of the observable universe. In one branch, you're watching this video right now. In another branch, you clicked on something else. In another branch, you were never born. Each branch has its own version of you, its own version of your cosmic horizon, its own version of the observable universe. The totality of reality would include not just the spatial regions beyond any single cosmic horizon, but also the quantum branches beyond any single timeline. The edge of the universe wouldn't just be a boundary in space and time. It would be a boundary across quantum branches, separating your version of reality from infinite other versions where things happen differently. This is highly speculative, and many physicists don't accept the many worlds interpretation. But it's a serious scientific hypothesis, and it suggests that the universe's edge is even more complex and multidimensional than we've been discussing. Now, I want to address something that might be bothering you. We've talked a lot about cosmic horizons and the limits of observation, but what about the edge of space itself? Does space end somewhere? Is there a literal edge to the universe beyond which there's nothing, not even empty space? The answer depends on the geometry of the universe. General relativity allows for three possible geometries: flat, open, or closed. A flat universe extends infinitely in all directions. Space goes on forever. There is no edge. An open universe also extends infinitely, but with a saddle-shaped geometry. It too has no edge. A closed universe, however, is finite but unbounded, like the surface of a sphere. Imagine you're standing on Earth and you start walking in one direction. If you keep going long enough, you'll eventually return to where you started, having circumnavigated the globe. But at no point did you encounter an edge. Earth's surface is finite. You can measure its total area, but it has no boundary. You can walk forever without falling off or hitting a wall. A closed universe works the same way, but in 3 dimensions. If you got in a spaceship and traveled in one direction for long enough, assuming the universe weren't expanding, you'd eventually return to where you started, having circumnavigated the entire universe. The universe would be finite in size, but have no edge. There'd be no place where space ends and something else begins. Current observations, particularly measurements of the cosmic microwave background, suggest the universe is very close to flat, meaning it likely extends infinitely. But the measurements aren't precise enough to rule out a very slight curvature, which would make the universe closed and finite. So we don't know for certain whether space goes on forever or loops back on itself. But here's the key point. In all 3 scenarios, there's no edge in the sense of a boundary where space stops. Either space extends infinitely, or it curves back on itself. There's no wall, no end, no place where you could reach out and touch the edge of space. The concept of an edge to space itself, a place where the universe ends and beyond which there's nothing, doesn't fit any of the models consistent with general relativity and current observations. So when we talk about the edge of the universe, we're really talking about horizons of observability, not edges of space. The universe doesn't have borders. It has horizons, boundaries not in space itself, but in what can be seen, what can influence us, what lies within our cosmic light cone. We're now about 110 minutes into this journey, and we've explored the universe's edge from multiple angles, from the practical limitations of light speed to the theoretical implications of inflation, from the philosophical questions about existence beyond observation to the personal meaning of cosmic horizons. But there's one more aspect of the universe's edge that we need to confront, and it's perhaps the strangest of all. The edge of the universe might actually be a doorway to understanding the fundamental nature of reality itself. Before we dive into this final mind-bending section, I want to acknowledge that you've stayed with this exploration for almost 2 hours. That's remarkable. It shows a level of intellectual curiosity and patience that's rare. If you've made it this far, you're exactly the kind of person this channel is for. Make sure you're subscribed, because we have so much more to explore together. Let's talk about something called the holographic principle. It's one of the most bizarre and profound ideas in modern theoretical physics, and it relates directly to the nature of cosmic horizons. The holographic principle suggests that all the information contained in a volume of space can be encoded on the boundary of that space, like a three-dimensional image encoded on a two-dimensional hologram. This idea emerged from studying black holes. In the 1970s, physicist Stephen Hawking and others discovered that black holes have entropy, a measure of the amount of information or disorder in a system. But strangely, the entropy of a black hole is proportional to the area of its event horizon, not its volume. This is bizarre. You'd expect the amount of information in a black hole to scale with how much stuff it contains, which should depend on volume. But instead, it scales with the surface area of the boundary. Jacob Bekenstein and Stephen Hawking worked out the math in the 1970s, showing that the entropy of a black hole equals 1/4 of the area of its event horizon in Planck units. This formula, known as the Bekenstein-Hawking entropy, revealed a deep connection between information, gravity, and the geometry of spacetime. In the 1990s, physicists Gerard 't Hooft and Leonard Susskind proposed that this principle might be universal. Maybe all of spacetime works this way. Maybe all the information in any region of space is actually encoded on the boundary of that region. The three-dimensional reality we experience might be a projection, a hologram, emerging from information encoded on a two-dimensional surface. Now, apply this to the universe's edge. Our cosmic horizon is the boundary of our observable universe. According to the holographic principle, all the information in our observable universe, everything that happens, every particle, every event, every thought you've ever had, might be encoded on that distant cosmic horizon, on the sphere of the cosmic microwave background that surrounds us. If this is true, then the edge of the universe isn't just a boundary of observability. It's the fundamental substrate of reality itself. The three-dimensional universe we inhabit might be a holographic projection from information encoded on that distant two-dimensional surface. You, your body, your thoughts, your entire life might be patterns of information dancing on the cosmic horizon, projected inward to create the illusion of a three-dimensional existence. This is not mysticism or pseudoscience. This is serious theoretical physics, emerging from attempts to reconcile quantum mechanics and general relativity, to understand the nature of information in the universe, and to solve paradoxes about black holes and entropy. The holographic principle is a key component of some versions of string theory and quantum gravity. But it raises mind-bending questions. If we're holographic projections from the cosmic horizon, what does that mean for consciousness? Are your thoughts and experiences real? Or are they just patterns of information on a distant surface? Does it even make sense to distinguish between being real and being a pattern of information? Maybe those are the same thing. And here's an even stranger implication. If the holographic principle is true, then the amount of information in the observable universe is finite. It's limited by the surface area of the cosmic horizon. This means there are only a finite number of possible configurations of matter and energy within our observable universe. Given enough time, if the universe were to persist indefinitely, it would eventually exhaust all possible configurations and start repeating. This leads to something called the Poincare recurrence theorem, which suggests that a finite system with finite possible states must eventually return to any previous state if you wait long enough. Applied to the universe, this means that if you wait an incomprehensibly long time, something like 10 to the power of 10 to the power of 120 years, The exact configuration of matter and energy that exists right now, including you reading these words, will occur again. Not a similar configuration, the exact same configuration. Every atom in the same place, every thought in your mind identical. You would live this exact life again, make the same choices, have the same experiences, read this same video, and it wouldn't happen just once. In an infinite future, it would happen infinite times. You would exist infinite times, living this exact life over and over forever. This is called eternal recurrence, and it was first proposed by the German philosopher Friedrich Nietzsche in the 19th century, long before modern physics. Nietzsche asked, if you had to live your life over and over again, eternally, with no variation, no escape, how would that change how you live? Would you live differently if you knew every choice, every action, every moment would be repeated infinite times? Now, there are big caveats here. Poincare recurrence requires a closed system with finite states that persists forever. But the universe is expanding, driven by dark energy. It's not clear if it's a closed system, or if it will persist forever in a state that allows recurrence. The Big Rip scenario we discussed earlier would prevent eternal recurrence by tearing apart the fabric of spacetime. But the holographic principle and Poincare recurrence illustrate how the universe's edge connects to deep questions about the nature of time, information, identity, and existence. The boundary of the observable universe isn't just a limit on what we can see. It might be the fundamental substrate that determines what's possible, how many different states reality can occupy, and whether existence is ultimately finite or infinite in its possibilities. Let me share one more mind-blowing idea about the universe's edge, and this one brings together many of the threads we've been exploring. It's called the cosmological principle, and it states that the universe is homogeneous and isotropic on large scales. Homogeneous means it's the same everywhere. Isotropic means it looks the same in all directions. No location is special. No direction is preferred. We've already discussed how this principle implies that every observer sees themselves at the center of their own cosmic horizon. But the cosmological principle has deeper implications. If the universe is truly homogeneous, then the properties of our observable universe, the density of matter, the strength of dark energy, the laws of physics, should be the same everywhere, even beyond our cosmic horizon. This means that what we observe within our cosmic bubble is representative of the universe as a whole. By studying the observable universe, we can infer properties of the unobservable universe. Our cosmic island isn't an outlier or exception. It's a fair sample of cosmic reality. But there's a problem. Inflation theory, which we discussed earlier, solves many cosmological puzzles, but also predicts the different regions of the universe. Regions beyond our cosmic horizon might have undergone different amounts of inflation or stopped inflating at different times. This leads to a concept called the multiverse. In the inflationary multiverse, our observable universe is just one bubble in an eternally inflating sea of spacetime. Beyond our cosmic horizon lie other bubbles, other observable universes, each potentially with different physical properties. In some bubbles, the electromagnetic force might be stronger. In others, dark energy might be weaker. In others still, the fundamental constants might be tuned differently, creating universes where stars don't form, or where complex chemistry is impossible, or where life as we know it cannot exist. This is called the landscape of string theory, a vast space of possible universes, each with its own configuration of physical laws and constants. Our observable universe occupies one point in this landscape. Other bubbles occupy other points. And the totality of physical reality includes not just our universe, but the entire landscape, all possible universes. If the multiverse is real, then the edge of our universe isn't just separating us from more space with the same properties. It's separating us from fundamentally different realms of reality, places where the laws of physics are different, where matter behaves differently, where the very fabric of existence has a different structure. This has profound implications for the anthropic principle, the observation that the universe seems finely tuned for life. If physical constants were slightly different, stars wouldn't form, or chemistry wouldn't work, or life would be impossible. Some people see this fine-tuning as evidence of design, a cosmic engineer who set the constants precisely to allow life. But the multiverse offers an alternative explanation. If there are countless universes with different physical constants, then it's no surprise that we find ourselves in one of the rare universes where life is possible. We couldn't exist in the others. This is called the weak anthropic principle. We observe the universe to be life-permitting because if it weren't, we wouldn't be here to observe it. The edge of our universe, in this view, is the boundary between our life-permitting bubble and a vast multiverse where most regions are hostile to existence. We live in a cosmic oasis, surrounded by an incomprehensibly large desert of universes, where complexity and consciousness never arise. Now, I need to be clear, the multiverse is speculative. It emerges naturally from inflation theory and string theory, but we have no direct evidence for it and may never be able to observe other universes. Some physicists embrace the multiverse as the best explanation for cosmic fine-tuning and the results of inflation. Others reject it as unfalsifiable speculation that's beyond the realm of science. But regardless of whether the multiverse is real, the fact that our best theories predict it tells us something important. The universe's edge, our cosmic horizon, might not just be separating us from more of the same. It might be hiding realms of reality radically different from anything we can observe. Places where physics works differently, where the fundamental structure of existence is alien. And here's the truly humbling realization. If the multiverse exists, then everything we can observe, every galaxy within our cosmic horizon, every star and planet and atom, all of it is just one tiny bubble in an infinite ensemble. The observable universe, already so vast it defies comprehension, is an infinitesimal speck in the totality of existence. You might think this makes you insignificant, and from a cosmic perspective, it's true that you're small. But consider this. In a vast multiverse where most regions are empty or hostile to life, the fact that you exist at all is extraordinary. The configurations of physical laws that permit your existence are rare. The chain of cosmic events that led from the Big Bang to the formation of Earth, to the evolution of life, to the emergence of consciousness to your birth, all of that was incredibly improbable. You exist against overwhelming odds. Your consciousness, your ability to understand these concepts, your capacity for wonder and curiosity, these are cosmically rare and precious. The universe's edge might separate you from infinite other realms, but you exist in this realm, experiencing this reality, and that's a privilege and a mystery. We're approaching 150 minutes now, and we've journeyed from the observable limits of our cosmic horizon to the speculative frontiers of multiverse theory. We've explored how the universe's edge relates to time, space, information, consciousness, and the fundamental structure of reality. But I want to spend the remaining time bringing this back to practical and philosophical implications for your life. The universe's edge teaches us several profound lessons. First, it teaches humility. You are not the center of the universe in any objective sense. Your observable universe is just one perspective among countless others. The vast majority of reality lies beyond your horizon, forever inaccessible. There are limits to what you can know, places you can never go, questions you can never answer. But the universe's edge also teaches us wonder. The fact that the edge exists, that there's a boundary to observability created by the finite speed of light and the age of the universe, is itself remarkable. It means we can look back in time. It means we can see the universe's infancy. It means we can piece together cosmic history from the light that reaches us across billions of years. The universe didn't have to be comprehensible. The laws of physics could have been so chaotic and unpredictable that understanding would be impossible. But instead, we live in a universe governed by mathematical laws, a universe where patient observation and careful reasoning can reveal the cosmos's deepest secrets. The universe's edge is knowable, mappable, understandable. That's a gift. Third, the universe's edge teaches us about connection. You are not separate from the cosmos. You are made of material forged in stars. You exist within the universe, subject to its laws, shaped by its history. Your cosmic horizon, the edge of your observable universe, is defined by your position in space and time. You are intimately connected to the structure of spacetime itself. And fourth, the universe's edge teaches us about perspective. Every observer has their own unique cosmic horizon. Reality is too vast and complex for any single perspective to encompass. Truth emerges from combining multiple viewpoints, acknowledging that no one sees the complete picture. This applies not just to cosmology, but to life. Your perspective is valid and valuable, but it's not the only one. Others see things you don't. The universe's edge reminds us to stay humble and curious, to seek out other perspectives, to recognize the limits of our own view. Now, let me ask you a question that might change how you think about your life. If you knew that you stood at the center of your own observable universe, that your cosmic horizon was unique to you, that your perspective on reality would vanish when you die, how would that change how you live? Would you take your experiences more seriously, knowing they're cosmically unique? Would you pay more attention to the present moment, aware that your particular window onto reality exists only now? Would you be more curious, more eager to explore and understand, knowing that you have a limited time to peer through your cosmic window before it closes? The universe's edge is a reminder of mortality. Just as there are regions of space that will eventually recede beyond your cosmic event horizon, forever lost to observation, there are experiences and opportunities in your life that will slip away if you don't seize them. Time moves forward. The cosmic horizon shifts. Galaxies that are observable today will be invisible tomorrow, and moments that are available to you now will be gone soon. This isn't meant to be depressing. It's meant to be motivating. Your time in this universe is limited. Your window of observation is narrow, but it's yours. You have the extraordinary privilege of being a conscious entity in a cosmos that has organized itself to contemplate its own nature. You can look at the stars, understand the physics of cosmic expansion, trace your atoms back to stellar furnaces, and marvel at the edge of everything. Not everyone throughout history has had this opportunity. Most humans who ever lived died without knowing the true scale of the cosmos, the age of the universe, or the nature of cosmic horizons. You live in a unique moment when this knowledge is available, when technology and theory have advanced enough to peer to the edge of observation and understand what we're seeing. Use that privilege. Be curious. Ask questions. Explore ideas. Don't take for granted the cosmic lottery you've won by existing at all, let alone existing in an era of scientific enlightenment. Your consciousness is a rare and precious phenomenon. The universe's edge exists because you exist to observe it. Without conscious observers, cosmic horizons would be meaningless, abstract mathematical constructs with no experiential reality. But you give meaning to the universe's edge. By understanding it, by contemplating it, by being awed by it, you transform an abstract physical boundary into something meaningful. You are the universe's way of understanding itself, of marveling at its own vastness, of comprehending its own edge. Let me share one final thought that brings together everything we've discussed. The universe's edge is fundamentally a horizon, a boundary between the known and the unknown, the observable and the unobservable, the accessible and the forever inaccessible. But horizons are not walls. They're invitations. Throughout human history, horizons have called to us. The horizon of the ocean called to ancient sailors, inviting them to discover what lay beyond. The horizon of the atmosphere called to aviators, inviting them to take flight. The horizon of Earth's gravity will call to astronauts, inviting them to journey into space. And each time humans have reached a horizon, we've discovered not an ending, but a beginning. Beyond each horizon lay new worlds, new possibilities, new mysteries. The cosmic horizon is the ultimate horizon, the final frontier. We cannot cross it physically. The laws of physics prevent that, but we can cross it intellectually. Through mathematics, through physics, through theory, we can peer beyond our cosmic horizon. We can infer what lies beyond. We can construct models of the unobservable universe, test them against observations within our horizon, and build understanding that extends beyond what we can directly see. This is the power of human reason, the ability to transcend the immediate, to understand the unseen, to grasp what lies beyond our direct experience. The universe's edge doesn't stop us. It challenges us. It asks, how far can your mind reach when your body cannot follow? How deep can your understanding go when direct observation is impossible? And we're rising to that challenge. Every year, our understanding of the universe's edge grows deeper. We build more sensitive telescopes, detect fainter signals, construct more sophisticated theories. The cosmic horizon may be receding, but our comprehension is advancing. We're in a race between cosmic expansion and scientific progress, and while expansion will ultimately win, the big rip or heat death awaits in the far future. For now, in this cosmic moment, understanding is gaining ground. You are part of that endeavor. By engaging with these ideas, by thinking deeply about cosmic horizons and the nature of reality, you're participating in humanity's grandest quest. You're pushing back against ignorance, embracing wonder, refusing to be satisfied with surface-level understanding. The universe's edge is stranger than you can imagine, but it's not stranger than you can understand. These concepts, inflation and dark energy, cosmic horizons and holographic principles, multiverses and eternal recurrence, they're challenging, but they're accessible. You don't need to be a professional physicist to grasp them. You just need curiosity, patience, and a willingness to have your assumptions challenged. And that willingness is crucial because the universe's edge forces us to confront the limits of intuition. Our everyday experience doesn't prepare us for cosmic expansion, for space that grows without expanding into anything, for horizons that exist in time rather than space. These concepts violate our intuitive expectations about how reality works. But that's okay. Intuition is a guide, not a master. It evolved to help us survive in a world of medium-sized objects moving at medium speeds. It was never meant to comprehend cosmic scales or quantum weirdness. The universe doesn't owe us intuitive understanding. Reality is what it is, regardless of whether it fits our preconceptions. So we have to expand our minds, stretch our conceptual frameworks, learn to think in new ways. That's what exploring the universe's edge demands. It's uncomfortable, it's disorienting. It challenges everything you thought you knew. But it's also exhilarating. Every moment of confusion, every concept that seems impossible is an opportunity for growth, a chance to transcend your previous limitations and achieve a deeper understanding. And here's something beautiful. The same principles that govern the universe's edge, the speed of light, the expansion of space, the behavior of gravity, these same principles govern your everyday life. Light reflecting off this screen travels at the same speed that limits our cosmic horizon. Gravity shaping cosmic expansion is the same force keeping your feet on the ground. The atoms in your body follow the same quantum rules that created the fluctuations in the early universe that became galaxies. There's no separation between the cosmic and the mundane. It's all one unified reality, governed by the same laws, made of the same fundamental building blocks. Understanding the universe's edge helps you understand the universe you inhabit, the reality you experience every day. It's all connected. We're now approaching 180 minutes, and I want to spend the final segment bringing this full circle. We started with a shocking revelation that the universe's edge isn't a place but a horizon, different for every observer, racing away faster than light. We built understanding layer by layer, exploring cosmic expansion, the Big Bang, inflation, dark energy, cosmic horizons, the holographic principle, the multiverse, and the philosophical implications of unobservable reality. Along the way, we've encountered some of the most brilliant minds in scientific history. Edwin Hubble, who discovered cosmic expansion. Arno Penzias and Robert Wilson, who found the cosmic microwave background. Alan Guth, who proposed inflation. Saul Perlmutter, Brian Schmidt, and Adam Rees, who discovered the acceleration of expansion. Stephen Hawking and Jacob Bekenstein, who connected black holes to information theory. Each of these scientists peered a little farther toward the edge, pushed understanding a little deeper, revealed a little more of the cosmos's strange nature. You now understand concepts that would have been incomprehensible to people just a century ago. You grasp ideas that are at the cutting edge of modern cosmology. You've journeyed from basic observational limits to speculative multiverse theory, from practical horizons to philosophical implications. And through it all, you've hopefully experienced moments of wonder, confusion, cognitive dissonance, and finally, understanding. That journey mirrors the scientific process itself. Science begins with observation, something puzzling about the world. Then comes confusion, as our existing frameworks fail to explain what we observe. Then hypothesis, new ideas that might resolve the puzzle. Then testing, checking whether the new ideas match observations. And finally, if we're lucky, understanding emerges. The puzzle resolves. Reality makes sense in a new way. The universe's edge has taken us through that entire cycle. We observed that we can't see infinitely far into space. We struggled to understand why. We developed theories about the Big Bang, cosmic expansion, and horizons. We tested those theories against observations of distant galaxies, the cosmic microwave background, and supernova, and we achieved understanding. The universe's edge makes sense. It's a consequence of the finite speed of light, the finite age of the universe, and the expansion of space. But that understanding immediately generates new puzzles. What lies beyond the horizon? Is the multiverse real? Is reality holographic? These questions push us forward, driving the next cycle of scientific inquiry. Understanding doesn't end curiosity, it feeds it. Every answer reveals new questions. And that's a profound lesson about life. You will never reach a point where you know everything, where there are no more mysteries, no more horizons to explore. There will always be an edge to your knowledge, a boundary between what you understand and what remains mysterious. And that's not a failure. That's the nature of existence in a complex, vast, ancient universe. Embrace the mystery. Don't fear the unknown. The edge of your understanding, like the edge of the universe, is not a wall. It's an invitation. It's calling you to keep learning, keep questioning, keep exploring. Every book you read, every video you watch, every conversation you have, every thought you think, all of it pushes your personal horizon a little farther out, expands your understanding a little wider. You are, in a sense, expanding your own personal observable universe of knowledge. Just as the cosmic horizon grows, as light from more distant regions reaches us, your intellectual horizon grows as you encounter new ideas and integrate them into your worldview. You are creating your own cognitive cosmos, and it can grow as large as you allow it. But remember, growth requires work. Understanding the universe's edge wasn't easy. It required patience, focus, nearly 3 hours of deep concentration. Most people won't invest that time. They'll settle for superficial understanding, for vague notions of the Big Bang and expanding space. But you didn't settle. You went deep. You pushed through the difficult concepts. You earned your understanding. That's the only way to truly grasp reality. Easy answers are usually wrong or incomplete. Deep truth requires deep thought. The universe's edge rewards those willing to put in the effort with understanding that transforms how they see reality. And transformation is what this is really about. You're not the same person who started watching this video nearly 3 hours ago. Your understanding of space, time, horizons, and reality has fundamentally changed. You can never unsee what you now understand. You can never go back to simple intuitions about the universe having a simple edge or a center. You've been initiated into a deeper truth. That transformation is permanent. It's part of you now, and it will ripple through your life in unexpected ways. You'll look at the night sky differently, seeing not just stars, but cosmic history. You'll think about limits differently, recognizing that boundaries can be horizons rather than walls. You'll approach mystery differently, with curiosity rather than fear. This is the gift of deep understanding. It changes you. It expands your mind, quite literally enlarging the space of concepts you can entertain. Your brain has formed new connections, new patterns of neurons that encode this knowledge. The universe has changed you by revealing itself to you, and in turn, you change the universe by understanding it. This sounds mystical, but it's literally true. Before conscious beings evolved, the universe existed, but it wasn't understood. Galaxies formed, stars exploded, space expanded, but none of it meant anything. There was no one to observe, to marvel, to comprehend. Then consciousness emerged, and suddenly the universe could see itself, understand itself, appreciate itself. You are part of that cosmic awakening. The atoms that make up your brain were once scattered across the cosmos. Now they've organized into a pattern capable of understanding cosmic horizons. The universe has become conscious of its own edge, and you are that consciousness. This brings us to the ultimate meaning of the universe's edge. It's not just a physical boundary, it's an existential one. It marks the limit of what can influence you, what you can know, what you can observe. But it also defines the arena of your existence. Within your cosmic horizon, within the sphere of space and time that can interact with you, that's your universe. That's where your life unfolds, where your choices matter, where your consciousness experiences reality. Beyond the edge lies infinite mystery, perhaps infinite reality, but it's inaccessible. It doesn't affect you. In a very real sense, it doesn't exist for you. Your universe is bounded by your horizon, and within that boundary, you are free to explore, to learn, to create meaning. The universe didn't come with meaning built in. There's no cosmic purpose, no grand plan, no predetermined destiny. But that's not a bug. It's a feature. It means you're free to create your own meaning. Within your cosmic horizon, within the span of your life, you can decide what matters, what's worth pursuing, what gives your existence significance. The universe's edge teaches us that limits can be liberating. You don't have to understand everything, or experience everything, or accomplish everything. You can't. The cosmic horizon guarantees it. So relax. Focus on what's accessible to you. Explore your observable universe, both literally and metaphorically. Learn what you can. Experience what you can. Create what you can. That's enough. That's everything. As we approach the end of this journey, I want to leave you with a challenge. Tonight, or whenever you next have the opportunity, go outside and look up at the night sky. Find a spot with minimal light pollution if you can. Let your eyes adjust to the darkness. And as you gaze up at the stars, remember what you now understand. You're looking back in time. Every point of light is a message from the past, photons that have traveled for years or centuries or millennia to reach your eyes. The farthest objects you can see with your naked eye are millions of light years away, showing you the universe as it was millions of years ago. And beyond what you can see, beyond even what our most powerful telescopes can detect, lies the cosmic horizon, the edge of your observable universe, showing you the cosmos as it was 13.8 billion years ago. You are surrounded by time, by history, by the unfolding story of the universe. And beyond that horizon lies mystery, perhaps infinite space, perhaps other universes, perhaps realities you cannot even imagine. But all of it, everything you see and everything beyond, is part of one magnificent cosmos, governed by laws you can understand, made of matter you are part of. You are not outside the universe looking in. You are inside it, made of it, experiencing it from within. You are stardust, contemplating stars, quantum fields organized into consciousness, the universe's way of knowing itself. As you stand there beneath the sky, remember that you occupy a unique position in space and time. Your cosmic horizon is different from anyone else's, past, present, or future. Your perspective on reality is singular. And when you die, that perspective will vanish. That particular window onto the cosmos will close forever. But right now, in this moment, it's open. You can see. You can understand. You can marvel. That's the gift of existence, the privilege of consciousness, the wonder of being a temporary pattern of matter complex enough to comprehend the edge of everything. Don't waste it. Don't sleepwalk through life distracted by trivialities. You exist in a vast, ancient, expanding universe, racing toward an unknown future, bounded by horizons that reveal the past. You have a brief window, a few decades if you're lucky, to explore this reality, to understand it, to experience its beauty and strangeness. The universe's edge is receding, carrying distant galaxies beyond the reach of observation, isolating us more and more from the cosmic whole. But your edge, the horizon of your knowledge and understanding, doesn't have to recede. It can expand. Every day, you can learn something new, understand something deeper, see something you missed before. That expansion of personal understanding is your contribution to the universe's awakening. Every time you grasp a difficult concept, every time you experience wonder at the cosmos's complexity, every time you share knowledge with others, you're pushing back the darkness of ignorance. You're creating light in the universe, quite literally as neurons fire and synapses strengthen, encoding new patterns of understanding. And that understanding matters. Not because it will change your bank account, or your social status, or your career prospects, though it might, but because understanding is intrinsically valuable. It's what separates us from rocks and trees, from mere matter blindly following physical laws. We can know those laws. We can trace their implications. We can see how they create cosmic horizons and distant galaxies, and ultimately us. This is what makes us human, this capacity for understanding. Not our tool use or our language or our opposable thumbs, remarkable as those are. It's our ability to grasp abstract concepts, to imagine what we cannot directly perceive, to build models of reality that extend far beyond our immediate sensory experience. You have that ability. You've demonstrated it by following this journey through nearly 3 hours of complex ideas. Your brain right now contains knowledge about cosmic expansion, inflation theory, dark energy, the holographic principle, concepts that didn't exist in human understanding until recently. You've compressed billions of years of cosmic history and centuries of scientific progress into mental models that fit inside your skull. That's extraordinary. Don't diminish it. Don't think, I'm just watching a YouTube video. You're doing something remarkable. You're participating in the grandest endeavor of our species, the quest to understand the cosmos we inhabit. You're standing on the shoulders of giants, Einstein and Hubble and Hawking and countless others, and seeing what they saw, understanding what they understood. And you can go farther. This video is just a beginning. There are books to read, papers to study, ideas to explore. The edge of your understanding is not fixed. It's dynamic, responsive to your effort. Push against it, challenge it, expand it. Your cosmic horizon may be determined by physics, but your intellectual horizon is limited only by your curiosity and dedication. Now, let's talk about what you should do with this understanding. How does knowledge of the universe's edge change your practical daily life? It might seem abstract, disconnected from paying bills and maintaining relationships and pursuing careers. But I'd argue that understanding cosmic horizons can fundamentally improve how you live. First, it provides perspective. When you're stressed about something trivial, remember the cosmic scale. Remember that you're standing on a planet, orbiting a star in a galaxy that's one of hundreds of billions within your cosmic horizon. Your problems, while real and important to you, are cosmically insignificant. This isn't meant to diminish your struggles, but to help you see them clearly. Most of what we worry about doesn't matter on any scale beyond our immediate lives. But here's the paradox. While you're cosmically insignificant in scale, you're cosmically significant in quality. You are one of the rare places, possibly the only place within our cosmic horizon, where matter has organized itself into consciousness. Your ability to experience, to understand, to care, that's precious beyond measure. The universe is mostly empty space and mindless matter. Consciousness is rare. You are rare. So take care of yourself. Not because you're the center of the universe, you're not, but because you're one of the few windows through which the universe can observe itself. Your consciousness is valuable, not to the universe, which has no preferences, but intrinsically as a phenomenon, as an accomplishment of cosmic evolution. Second, understanding the universe's edge teaches you to embrace mystery. You will never know everything. Some things are forever beyond your reach. The cosmos beyond your event horizon is inaccessible. The first few moments of the Big Bang are hidden behind an impenetrable veil. The ultimate fate of the universe is uncertain, and that's okay. You don't need certainty to live well. You don't need complete knowledge to make good decisions. You can act with confidence despite ignorance, can find meaning despite mystery. The universe's edge is the ultimate reminder that not knowing is the natural human condition. We live in a vast cosmos we barely understand, and that's not a problem to solve. It's a feature of existence. Third, cosmic horizons remind you of connection. You share this observable universe with billions of other humans, each with their own unique perspective, their own cosmic horizon slightly different from yours. And you share it with whatever other intelligent beings might exist out there among the stars, each of them also surrounded by their own horizon, observing their own version of the cosmos. Despite the distances, despite the differences in perspective, you're all part of the same universe, subject to the same laws, made of the same fundamental stuff. When you look up at the night sky, you're seeing photons that have traveled across space to reach you. Those same photons could reach an alien on a distant planet, creating a connection across the light years, a shared experience of cosmic beauty. This should foster compassion. Every person you meet is a unique cosmic horizon, a singular perspective on reality that has never existed before and will never exist again. When they die, their observable universe vanishes with them. Their perspective is lost forever. So treat people with the respect and care their cosmic uniqueness deserves. Fourth, understanding the universe's edge can help you make better decisions about how to spend your time. You have perhaps 80 years, give or take. That's your observable lifespan, the horizon of your personal existence. Within that boundary, you can have a finite number of experiences, learn a finite amount, accomplish a finite amount. So choose carefully. Don't waste your horizon on things that don't matter. Don't spend your precious observational window staring at screens full of trivia or getting angry about things you cannot change. You have limited time to explore reality, to understand the cosmos, to experience beauty, to create, to love, to live. The universe's edge is receding. Galaxies are disappearing beyond the cosmic event horizon, lost to observation forever. Your personal horizon is also finite and shrinking. Every day that passes is one less day you have to explore, to learn, to experience. This should motivate urgency, not anxiety, but intentionality. Live deliberately. Choose what matters. And what matters? That's for you to decide. The universe won't tell you. There's no cosmic purpose, no divine plan, no objective meaning. But there's subjective meaning, the meaning you create through your choices, your values, your actions. You can decide that understanding matters, that kindness matters, that beauty matters, that exploration matters. And by living according to those values, you create meaning within your cosmic horizon. Fifth and finally, the universe's edge teaches you about scale and context. Humans are terrible at intuiting scale. We treat everything as if it's roughly the same size and importance. But understanding cosmic horizons forces you to grapple with vastly different scales, from the quantum fluctuations that seeded galaxies to the billions of light years spanning the observable universe. This ability to think across scales is valuable in everyday life. It helps you distinguish between small problems and large ones, between short-term concerns and long-term consequences. It helps you see patterns, to recognize when you're focused too narrowly and need to zoom out, or when you're too abstract and need to zoom in. The universe's edge is the ultimate zoom out, the farthest possible perspective. By understanding it, you train your mind to shift perspectives, to see your life from different distances, different timescales. Sometimes you need to be immersed in the immediate moment. Other times you need to step back and see the larger pattern. The ability to shift between these modes is crucial for wisdom. We're now past the 3-hour mark, approaching our conclusion. But before we finish, I want to address one final question that might be nagging at you. With everything we've discussed, with all the vastness and mystery and uncertainty, does any of this actually matter? Does understanding the universe's edge change anything fundamental about your life? The answer is both no and yes. No, in the sense that your immediate circumstances don't change. You still have to pay rent, maintain relationships, deal with daily challenges. The cosmic horizon doesn't solve your problems or eliminate your struggles. But yes, in a deeper sense, understanding changes you. It expands your mind, deepens your perspective, connects you to something larger than yourself. You can never unknow what you now understand. The universe will always be stranger and more magnificent than it was before you took this journey. And that matters because meaning doesn't come from circumstances. It comes from how you interpret and engage with those circumstances. Two people can live identical lives in identical circumstances and have completely different experiences based on their understanding, their perspective, their frame of reference. By understanding the universe's edge, you've changed your frame of reference. You now see yourself as part of a cosmic story, as stardust that has become conscious, as a unique perspective on an ancient expanding universe. That framing changes how you experience everything. A sunset isn't just pretty colors. It's light that left the sun 8 minutes ago, scattered by Earth's atmosphere, photons traveling at cosmic speed limits to reach your eyes. A tree isn't just a plant. It's organized matter built from carbon atoms forged in stellar cores, powered by photons from our local star, a temporary configuration that will eventually decompose and return its atoms to the cosmic cycle. Everything becomes more meaningful when you understand the cosmic context. Every moment is miraculous, not in a supernatural sense, but in the sense of being part of an intricate cosmic dance, governed by elegant mathematical laws that somehow produced consciousness capable of understanding those very laws. This is what the universe's edge ultimately teaches us. Reality is strange, vast, ancient, and comprehensible. We are small but significant, temporary but precious, isolated by cosmic horizons, yet connected to everything through physics and shared origins. We will never know everything, but we can know enough to marvel, enough to understand, enough to find meaning. The edge of the universe isn't just out there in space. It's in your mind, the boundary between what you understand and what remains mysterious. And that edge, unlike the cosmic horizon, can be pushed. Every question you ask, every book you read, every idea you explore, pushes that edge farther out, expands your personal universe. So keep pushing, keep asking, keep exploring. The universe is revealing its secrets to those willing to look, to think, to understand. You have a brief window, a cosmic moment, to participate in this grand revelation. Use it well. As we close this journey, I want to thank you for your time, your attention, your intellectual courage. 3 hours is a significant investment, and the fact that you've stayed this long tells me you're someone special, someone who values deep understanding over shallow entertainment, someone who's willing to grapple with difficult concepts because the payoff is worth it. You're exactly the kind of person humanity needs, someone who looks up at the stars and asks, why and how, and doesn't settle for simple answers. Someone who recognizes that the universe is stranger and more wonderful than everyday intuition suggests. Someone willing to expand their mind to accommodate ideas that initially seem impossible. If you found value in this exploration, if it changed how you see the universe even slightly, please hit that like button and subscribe to the channel. We create deep, thoughtful content exploring the biggest questions and mysteries of existence. And the algorithm needs to see engagement to share this content with others who would value it. Also, share this video with someone who would appreciate it. Not everyone has 3 hours to invest in understanding cosmic horizons, but those who do form a special community of deep thinkers. Help us grow that community by sharing this with someone you know who loves intellectual exploration. And finally, leave a comment sharing your biggest takeaway or your most mind-blowing moment from this journey. I read every comment, and I'm genuinely curious what resonated most with you. Was it the realization that you stand at the center of your own observable universe? The idea that space can expand faster than light? The holographic principle suggesting we might be projections from a distant boundary? The possibility of infinite copies of you in an eternal multiverse? Whatever it was, share it. Your insights might help others appreciate aspects they missed, and the conversation in the comments becomes part of the value of these videos, a community of curious minds exchanging ideas and perspectives. Now, as I promised at the beginning, let's bring this full circle. We started with a shocking revelation. The universe's edge isn't a place. It's a perspective different for every observer, racing away faster than light. We spent 3 hours building understanding, layer by layer, exploring cosmic expansion and inflation, dark energy and event horizons, the Big Bang and the cosmic microwave background, holographic principles, and multiverse theories. And we've discovered that the universe's edge is stranger than you could have imagined. It's not a wall or a boundary. It's a horizon in time, showing us the cosmos's infancy. It's a limit on causality, separating us from regions that can never influence us. It's possibly a 2-dimensional surface, encoding 3-dimensional reality. It's potentially a boundary between our universe and infinite others with different physical laws. But more than any of that, the universe's edge is a mirror. When we look at it, we see ourselves reflected back. We see the limits of observation, the constraints of existence, the nature of consciousness. We see that we are both cosmically insignificant and uniquely precious, both isolated by horizons and connected to everything. The universe's edge asks us who we are and what we'll do with our brief window of existence. It challenges us to think bigger, to embrace mystery, to seek understanding. It invites us to be worthy of the cosmic accident that produced consciousness, to honor our stardust origins by exploring the cosmos we came from. So tonight, when you look up at the stars, remember everything you've learned. Remember that you're seeing history, that light has traveled for years to reach you. Remember that beyond the visible sky lies a vast cosmos extending to the limits of observability. Remember that you stand at the center of your own universe, unique among all perspectives. And remember that you are the universe looking at itself, cosmic matter organized into consciousness, temporary but real, small but significant. You are one of the ways the universe knows itself, one of the rare places where blind matter has become aware. That's the ultimate meaning of the universe's edge. It exists because you exist to observe it. And you exist because 13.8 billion years of cosmic evolution, from the Big Bang through stellar nucleosynthesis, through planet formation, through biological evolution, eventually produced you. The edge of the universe is your edge, the boundary of what you can know, what you can see, what you can experience. And while that boundary is vast, extending billions of light years in all directions, it's also intimate, defined by your presence, your perspective, your consciousness. You are the universe's edge made conscious. You are the horizon come alive. You are the boundary between matter and meaning, between physics and experience, between the cosmos and the conscious. And that's stranger, more wonderful, more significant than any simple edge could ever be. Thank you for journeying with me to the edge of everything. Thank you for your time, your attention, your willingness to have your mind expanded. Keep looking up. Keep asking questions. Keep pushing against the edges of understanding. The universe is waiting to be discovered, and you're part of that discovery. Until next time, stay curious, stay humble, and never stop exploring the magnificent cosmic mystery we call home.